Hello everyone. Today we will talk about production of cyclic cAMP as second messenger. We will see the cascade of reaction that leads to the production of cyclic cAMP which acts as second messenger. So here we'll also talk about the hetero trimeric G protein. Okay, the trimeric G proteins are associated with the cytosolic phase of the membrane. So this is the cytosolic phase. You can see this is the cytosolic phase. So the G protein is associated to this side, not this side. This is the cytosolic phase, and the heterotrimeric G protein is associated to the cytosolic phase of the membrane, and it is named for its ability to bind guanine nucleotide. Okay, its function depends on the ability to dissociate into an alpha monomer and beta gamma dimer. This is the beta gamma dimer which you can see, and this is the alpha monomer. I mean, when it dissociates, it forms the alpha monomer and beta gamma dimer. All right. When the receptor is activated, the GDP is replaced by GTP. This GDP is replaced by GTP. Okay, in its inactive state, the alpha subunit of G protein is bound to GDP. See, this is an inactive state. This heterotrimeric G protein is in its inactive state. Therefore, the alpha subunit is bound to GDP. But when activation occurs, when it becomes active, okay, what happens? This GDP is replaced by GTP, and thus alpha GTP subunit dissociates and a free beta gamma dimer exists. So this is what happens. Now we will see the steps of the reaction. I mean, the reactions will be studied in detail now. Okay, see, this is the ligand. We'll start with the ligand. This is the hormone. The ligand is a hormone here, and this is the receptor or the receptor protein that will receive the hormone, with which the hormone will bind. This is extracellular. This hormone is extracellular. Now the ligand binds to the membrane protein receptor. This is the membrane, plasma membrane as labeled here, you can see, and this is the membrane protein receptor to which the hormone will bind. This ligand receptor complex activates G protein molecules in a very short period. What will happen? See, once this comes and binds here, this will produce conformational change in the receptor. The conformation of the receptor will change. Okay, this will produce conformational change in the receptor. Fine. Then what will happen? The G protein is converted into the active form, where an interaction with the activated receptor causes its bound GTP to be replaced with GTP. As I said right at the beginning, what will happen? This GTP, bound GDP, this is bound now. The bound GDP will be replaced with GTP. Okay, now come to the step. See, the hormone comes and binds to the receptor. This binding will cause some conformational change, and see, then what will happen? GDP bound to G protein is replaced by GTP. This is what I was trying to say. And subunits of G protein dissociates. These are the subunits: alpha subunit, beta, gamma. Okay, now see, they dissociate, and what is the resultant subunits now? The alpha subunit remains associated with GTP, and beta gamma, this dimer, this beta gamma subunits form a dimer. Okay, they exist as a free dimer here. right? Now see, now what happens? The alpha subunit binds to adenylyl cyclase, activating synthesis of cyclic AMP. Okay, and the hormone tends to dissociate in the next step. So till here the hormone remains bound to the receptor. As you come to this step, you see the hormone tends to dissociate from the receptor, and this alpha subunit, what is this doing now? This was what? See, right at the beginning you see the labeling properly. This is adenylyl cyclase, right? Now this alpha subunit that is associated with, or that is bound to GTP, goes and activates, or goes and binds to adenylyl cyclase, thus activating the synthesis of cyclic AMP. Okay, the cyclic AMP is the second messenger that we are talking about here, correct? So this goes and binds to adenylyl cyclase here. See, then what will happen in the next step? See, hydrolysis of GTP to GDP causes alpha subunit to dissociate from adenylyl cyclase and bind to beta gamma dimer again. This will regenerate the original structure, regenerating a conformation of G protein that can be activated by a receptor hormone complex. So it is again going back to its original form, which can once again be activated by another set of ligand binding. Alright. See, the intrinsic GTPase activity of the alpha subunit hydrolyzes GTP to GDP. Okay. So once the GTP gets hydrolyzed, we again get back the step with which the cascade commenced or started. So see, this receptor is once again ready for another set of hormone binding or ligand binding. Okay. So this reaction is to be noted. I hope this explanation is clear. I have tried to give you a very brief and quick revision. Thank you so much for attending the lecture. Till then, goodbye.